All right, so we are in Algebra 2. Today's date is Tuesday, October. So it's not 9, it's 10/1, 2019. We're talking about complex solutions to quadratic equations. So, objective, who's got it? Ellery.
Use the quadratic formula to find complex solutions of quadratic equations.
There it is. So that
Captain.
sounds like a mouthful.
Captain.
Yes, Captain. Thank you.
Oh, I don't have to say it though. I don't have to say it.
She's not one of the people that has to say it. It's Beverly and a few other people. All right. So, yeah. So what is a quadratic? Can anyone graph right now? What does a quadratic look like? Is it like this? What does a quadratic look like? Can you trace it in the air? Let me see someone trace it in the air. Colby, put it away. Someone trace a quadratic in the air. You did it last year, and the year before that you're supposed to do it, but we did it last year, definitely. At the very end of geometry. So you had extra time. Not a single person is tracing this correctly.
Oh, is it like that?
I think India kind of has it.
Or is it like
Okay, here is a quadratic. Ready? Roop. Quadratic. Roop. There are some quadratics.
I did both.
They are parabolas. Okay, it wasn't. That was my bad then. Okay, so we are dealing with these quadratics. Specifically, we want to know where the x-coordinates are of the intercepts of the quadratic function with the, anyone want to take a guess? There is a hyphen in there that gives you an idea. Quiet raise hand, it's some, I need more hands. I'll give you the second word. Everyone write down the second word. Axis. Now someone else guess the other one. Colby.
Why?
Close. Other one.
Wait. Oh.
What's the other one, Colby? If it's not y, it's, yeah. Everyone write down. We're finding the x-axis, the x-intercepts.
I hope
Bless
you
you,
get better.
Samantha.
Bless you.
So,
Bless you so.
thank you, everyone. So positive, I love it. All right, so we have some quadratic equation right here. ax squared plus bx plus c, and I'm going to set that equal to 0. If I set it equal to 0, I'm looking for the x-intercepts. Where do these shapes cross the x-axis? That's the main question we're dealing with today. Before, we weren't able to do things when we got a square root of a negative. You guys now know how to understand what a square root of a negative is. If I get the square root of negative 36, you'll be like, that's 6i. I did that in lesson 1. So we're advancing our knowledge. I'm going to teach you the quadratic formula. In the previous years, I only taught you how to complete the square. And quadratic formula comes from completing the square over and over, so you find the pattern. There's a song that goes along with it that I'm going to make everyone sing. Here it is for now. X. I will sing the song to begin with, and then you guys will sing with me after that. It will be beautiful. X is equal to negative b. Give yourself some room because I'm going to do a fraction, so give yourself room. Negative b plus or minus. This is going to be a giant square root of b squared minus 4 times a times c. These are all multiplied together. Those last 3 are multiplied together. And then everything, including the negative b at the very beginning, everything is divided by 2a.
It didn't even rhyme.
Are you guys? It's not going to rhyme, but it is going to be a song that you guys are going to have to learn. Question?
Do we
The
have to
song
learn
has to
it?
be sung in pirate accent.
Yes, it has to be sung in the pirate accent as well.
Do we have to learn it?
Yar har fiddle dee, being a pirate, so fun to be. All right, so here we go. But you can temporarily not speak in the pirate accent because it's kind of hard to sing as well. Okay, here's the song. Are you guys ready? X is equal to negative b plus or minus square root b squared minus 4ac all over 2.
Can you sing that again?
You gotta do it again.
So we're going to do it again as a class
No,
now.
wait.
I
Sing
don't
it.
know it. I don't know.
Just you sing it, because
One more time.
Yeah, one more time.
X is equal to negative b plus or minus square root b squared minus 4ac all over 2a.
I know it's a
One
song.
more
It's a
time.
song. It's a song.
One more
One more
time.
time. One more time.
One more time.
Wait,
We're all doing it now.
Wait.
We're all doing it now.
Wait,
Wait, one more time and then
Wait, one more time. Just you.
No, you're going to record it. All of us together.
Wait.
On the count of 3. 1,
Wait,
2, 3.
Wait.
X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Again, come on, we got this. One more time.
One more time by yourself.
I'll give you
No.
that.
Here we go.
Wait, no. Can you just say it by yourself, please?
No.
Please?
No.
Just one more
All
time.
together. One more time. You guys gotta get this down.
Please.
I want you to be singing this when you're doing the quadratic formula on the test. Here we go again. Everyone at the same time. 1, 2, 3. X is equal to negative plus or minus square root b squared minus 4ac all over 2a.
Wait, you just sing by yourself one more time?
One more time.
Maybe
Please,
later.
by yourself? Please?
Maybe later.
No, right now.
So, we are going to use this quadratic formula. This is called the quadratic formula from our objective. We are using this quadratic formula to find the solutions. By the way, make this note as well. This b squared minus 4ac, go ahead and put a box around that or a circle or something. This has a very specific name. And I'm totally blanking on what it's called right now. Oh no. What is that thing called? I will come back to this, but that is called something very particular. I'll look at it when we're done with example 1. But this is the main thing. If this b squared minus 4ac, if this is a negative, then I'm going to have a square root of a negative. That will make a complex answer. We'll watch a video on what that actually means, but let's go ahead and apply this to 2 problems to make sure you can do the homework. We'll watch a video. I might see the song again if you guys are nice. Here we go. Find the solutions to this quadratic equation. Notice that a, b, and c come from the coefficients of our quadratic. So, the first thing that I'm going to do down here is I'm going to identify what are a, b, and c. Quiet raised hand, easy XP. What are a, b, and c? Bless you, Leo. Bless your soul.
Bless you, Captain Leo.
There it is, Captain Leo. Not Captain Daddy, it's Captain Leo.
Bless you, Leo.
All right, what are a, b, and c? What are the coefficients? What are the constants? Come on, quiet raised hand. What are a, b, and c? Anna,
So A is -5.
label it.
B is 3.
Single swan down.
C is 2.
C is
Negative.
-2. It includes that negative. Good. So we have A, B, and C. We are plugging them into our song formula. Laptop shut it, really. Here we go.
Wait, are you going to sing it again?
I will sing it at the very end if you guys are nice. Captain Sindel. So here we go. X is equal to. Someone help me fill in the blanks. One letter at a time. Ellery's up.
So it's B, which is 3, and it's negative, so we'll have -3.
-3. Perfect. And then I'm going to do plus or minus. Ellery gets 50 XP. Next volunteer. What am I going to write inside of this giant square root? Let me make that square root slightly better. What goes inside that giant square root? Someone help me.
B squared minus 4ac.
What is b squared? Who can do that? Quiet raised hand. Sam.
Is it 3x squared?
It's just the coefficient. So it's just the 3 squared. Perfect. Yeah, thank you, Sam. 50 XP to Sam. And I'm going to subtract. I just did b squared. I'm going to do minus 4ac. So minus 4. Well, give me a quiet raised hand. What are a and what are c? What am I plugging in? Lorea, go for it.
And -5 is 2.
And, careful, -2. Perfect. And all of this is going to be divided by 2 times what? Quiet raised hand. Easy things to plug in. Beverly.
-5.
-5. 2 times the quantity of -5. We have successfully plugged in all of our variables for the quadratic equation, the quadratic formula. Now we need to simplify. So let's go ahead and do some simplification. Here we go. X is equal to, it's still -3, and I'm going to split this in half. This is usually what Khan Academy does. This half is going to be divided by -10. Plus or minus this half, which is still divided by -10. I just split my fraction. You're allowed to do this. Is it a question? Yeah.
Where does the -10 come
Good question. Someone else answer. Where did the -10 come from? Beverly, explain.
from? The 2 and the -5 are
Arr. The 2 and the 5. Arr.
Are you being rude? Are you being
negative 2, negative 5. 3 up, negative 5.
Minus HP.
What is my name, Beverly?
Leo.
No, you're good. You're good. She said Captain Sindel.
She's wheezing at Beverly. That's the sign.
All right, let's come back here. We now need to do 9.
Yeah, you know me.
Stop wheezing.
I need someone to multiply these 3 numbers together. Who can multiply these things together? Well, negative 4, or maybe you can just do the 4 and leave the negative. I'm going to do negative 4 times negative 5 should be altogether 20, a positive 20. I have a negative 4 times a negative 5, which is a positive 20. What is a positive 20 times a negative 2? Negative 40. There it is. So I'm going to write this down. It's going to be 9 minus 40, all of that inside of the square root. Is there a question, Colby?
No. I didn't see the square root, so I thought, why is that a 9?
Ah, yes. So we have 9 minus 40, and if I simplify this one more time, I'm going to have to do it 2 more times, so give yourself some room. This is going to be equal to positive 3 divided by positive 10. Positive 3 divided by positive 10. What's going to be on the inside of the square root? Everyone shout it out. Inside the square root is going to be?
What?
Is negative 31. Oh, sorry.
Negative 31. Yeah, it was a shout-out question. All of that divided by negative 10.
It was a shout out.
It was a shout-out question.
I didn't hear you say shout out.
I'll say it twice next time then, instead of once. And then from here, you guys should be able to simplify a square root of a negative because you've done that in lesson 1. So this is 3/10 plus or minus. And sometimes what Khan Academy loves to do, they say, oh, well, because you got a negative right here, I'm going to switch these so it's minus or plus. It doesn't matter. It's the same thing. So if you want to be Khan Academy correct, you can change this to minus or plus and then leave the 10 on the bottom without a negative. But it doesn't really matter. But who can simplify the top? The numerator. It's not square root of negative 31. There should be an I somewhere in it. Quiet raised hand this time. Who can do this? I see 3 people. Can I get 4? Can I get 4? Can I get 4 people? I only have 3 hands. How do I simplify a square root of a negative? Anna.
So you can use the factor 3 with 3 branches.
You do indeed?
I haven't done it yet.
What times what is 31?
That would be,
It's a prime number, I think.
yeah, so 31.
Yeah, 31 and 1. I can't factor it, but I can take out the square root of the negative. What happens when I get a square root of a negative 1?
That would be just
What is the definition of square root of negative 1?
that would be
I. So I have I on the outside, and what's left on the inside?
31.
There it is. Everyone write it down. That is your final answer. That is the answer. Sometimes you won't have a negative, and I'll repeat that. Sometimes you will not have a negative under the square root. If it's positive, it's the same thing without an I. So if it's positive, it's even less work. If it's a negative, though, you will have this I that pops out. Chewy Hood. You guys, try doing number 2 right now. Do example 2. Show me that you know how to do it. If everyone can be positive and hardworking, I will make sure that everyone gets their 100 XP from Captain Leo, and I will sing the song. If you guys are positive and hardworking.
Sing it.
If you're positive and hardworking. Ejemplo número 2. Here we go. I'm setting up my equation. X is equal to, we're doing tons of quiet raised hands. Aurelio.
Negative 5.
-5. Next, plus or minus square root of what? And Leo's tapping away like crazy, keeping up. Ellery.
5 squared. You want all of it?
5 squared, just one at a time. Minus Oscar.
4.
4. Do the next 2.
2.
And negative 1. And this is all going to be divided by what? Quiet raised hand. Sam?
2. Wait. Yeah.
2 times 2. There it is. I need to now simplify. Oh, is she one of the pirates? All right, sorry, Sam. You have to address me as captain.
Mr. Sindel? Bobby was taking off.
All right, so from there I need to simplify. So I still have the -5 out front. I need to now simplify the inside. Can someone tell me what is this thing? 5 squared minus 4 times 2 times -1. Who wants to do this? Beverly?
R 25. R plus 8. R.
25. It is plus 8. Thank you. And that's divided by what, Beverly?
It's the same.
4.
Divided by 4.
Captain.
Thank you, Beverly. Crewmate Beverly, you have done an excellent job. All right, Sam, tell me another step. What is the square root in here?
I think I did something wrong.
Oh, can you add 25 and 8 for me?
R. Is it negative? Also, you have a very nice R. 33.
It is indeed 33. And what is my name?
Captain.
Yeah, that's right. There it is. Final answer, box it. You did not need any imaginary numbers that time because that one actually has real intercepts. You can actually have an x-intercept without journeying to the complex plane. All right, guys, we're ready to watch a cool video that explains what it means to have a complex answer, like example 1. I will sing the song right after the video, of course. All right, so sit back, relax. You're not taking notes. You're paying attention, though. Let me turn off my lo-fi hip-hop radio.
Was that a phone?
Who has their phone?
Let's say we're given the function f of x is equal to x squared plus 1. We can graph our function and get a nice parabola. Now, let's say we want to figure out where the equation equals 0. We want to find the roots. On our plot, this should be where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis. So according to our plot, there are no solutions to the equation x squared plus 1 is equal to 0. But there's a small problem. A little over 200 years ago, a smart guy named Gauss proved that every polynomial equation of degree n has exactly n roots. Our polynomial has a highest power, or degree, of 2, so we should have 2 roots. And Gauss's discovery is not just some random rule. Today we call it the fundamental theorem of algebra. So our plot seems to disagree with something so important, it's called the fundamental theorem of algebra, which might be a problem. What Gauss is telling us here is that there are 2 perfectly good values of x that we could plug into our function and get 0 out. Where could these 2 missing roots be? The short answer here is that we don't have enough numbers. We typically think of numbers existing on a one-dimensional continuum, the number line. All our friends are here. 0, 1, negative numbers, fractions, and even irrational numbers like root 2 show up. But this system is incomplete. And our missing numbers are not just further left or right. They live in a whole new dimension. Algebraically, this new dimension has everything to do with a problem that was considered impossible for over 2,000 years, the square root of -1. When we include this missing dimension in our analysis, our parabola gets way more interesting. Now that our input numbers are in their full 2-dimensional form, we can see how our function x squared plus 1 really behaves. Our function does cross the x-axis. We were just looking in the wrong dimension. So why is this extra dimension that numbers possess not common knowledge? Part of the reason is that it has been given a terrible, terrible name. A name that suggests that these numbers aren't even real. In fact, Gauss himself had something to say about this naming convention.
He doesn't read it. That the subject, imaginary numbers, has hitherto been surrounded by mysterious obscurity is to be attributed largely to an ill-adapted notation. If, for example, +1, -1, and the square root of -1 had been called direct for +1, inverse for -1, and lateral units instead of positive, negative, and imaginary, or even impossible, such an obscurity would have been out of the question. Arr.
So yes, our missing dimension is comprised of numbers that have been given the ridiculous name imaginary. Gauss proposed these numbers should instead be given the name lateral, so from here on, let's let lateral mean imaginary. To get a better handle on imaginary, I mean lateral numbers, and really understand what's going on here, let's spend a little more time thinking about numbers themselves. Early humans really only had use for the natural numbers, that is 1, 2, 3, and so on. This makes sense.
I'm going to pause right here. There's more of the video, and there's like a bunch of parts in this video series. If you want to learn more, just search up, what is the title for this? It's called Imaginary Numbers Are Real, if you want to learn more. But that's going to be all I want to show you. There is a shadow dimension. There it is. All right, so that concludes the notes. You guys were awesome. Let's go ahead. Yeah, do you want me to sing to my computer or to you guys?
Right here.
Yeah, let's go ahead and do it.